Okay, geometry students, welcome to our second week of our third unit. Our unit is lines and angles. We're specifically looking at parallel lines right now. So last week we looked at angles, special angle pairs, right? Which angles are congruent or equal when you have those parallel lines being cut by a transversal. So that's what we mainly looked at last week. Remember, we also do need those symbols to indicate that these are parallel. And we did find that all of these angles were congruent, as were all of these angles, right? We had lots of matching angles. So here are our parallel lines. We talked about how they're lines that never touch, right? They go on and on forever. They never intersect. The reason they don't intersect is because those angles are creating that scenario where they're not intersecting. So now we're going to look at how to graph parallel lines. So we're going to look at parallel lines in the coordinate plane. So we're going to practice seeing how we can spot if lines are parallel based on their equation in slope-intercept form. So one background skill that this video is going to need you to feel good on, sorry, awkward pause, a background skill is slope-intercept form. Right? Y equals mx plus b. So quick refresher just in case it's been a while. I also do have some slope-intercept form videos on my YouTube channel. I can show you those real quick. So on my channel I've got lots of different playlists if you go to my YouTube channel, but I should have one that is labeled as a review of Algebra 1. Okay, here it is. It's on my next page. It's called Geometry Algebra Review. And if I just look at the different videos that are here, you'll see that I have videos on slope, videos on slope-intercept form, distribution, and vectoring. So that's where you can find a review of slope-intercept form if it's been a little while and you just want a quick refresher. I'll kind of try and weave it into this video though. So our m value is our slope, right? That represents your rise over your run, right? Up and to the right. And then your b value, that's representing your y-intercept. That's the point on the y-axis. So for this one, I'll plot this one right here. That means that there is a point 0, 8. So 5, 6, 7, 8. The reason why, if I were to make a table for this value of inputs and outputs, if I plugged in a 0 as my input for x, I would have negative 2/3 times 0 plus 8. Notice anything times 0 just becomes 0, which means it's an output of 8. And then from here, you can also use a table, but notice it's a little tricky because you're going to have to multiply things by 2/3. Another nice thing about the slope is that the slope means when you have negative 2/3 that you go down 2, right 3. So I'm going to go down 2, right 1, 2, 3, and that's going to be my second point on my line. So I can connect those 2 points here. I'm going to do the same thing for my second line. The y-intercept is at negative 1. I'm going to make a note of my point. And then my slope of negative 2/3, that's the same thing as down 2, right 3. So down 2, right 1, 2, 3. And I'm going to connect those. Get that drawn. Now, what you'll notice about these lines is that they look like they're parallel. So the question is, what about the equations ensures that they are parallel, right? There's something that they have in common. If we notice, they both have the same slope. So make a note at the bottom of your page. In order for two lines to be parallel, they need the same slope. Think back to when we did perpendicular lines. Perpendicular lines, if they had a right angle, that was when they had opposite reciprocal slopes. That's something like 2/3, and then negative, opposite, negative, and then reciprocal is 3/2. So we've kind of seen ideas before about how the slopes relate to each other, right? In this case, it's a little bit easier than with perpendicular. And it kind of makes sense, right? If two lines are going to continue on a certain path, they have to have that same pattern of how much they go up and over to ensure that they're never going to hit each other. So I've got some practice problems just to make sure we're feeling good on this new concept. So we have a line graph below. A good double check, test yourself. What's the equation of the line in purple? Try and test yourself on your equation writing skills. Try and write that in slope-intercept form. Unpause when you're ready to check. Okay, and there's your answer. Slope is 3/1. Notice every point you go up 3/1. And your y-intercept is at -5. And now we want to take this line and graph a line that is parallel to the purple line, and it has to go through a specific point. It has to go through -1, so left 1, and then up 4. Remember, that's your x, and this is your y. So if I have a point, all I need to do, they only asked me to graph. They did not ask me for an equation or anything. I just need to start at -1, 4, and I need to use the slope to get a second point. And this is actually really nice. It's a little bit harder to get the equation. I want to have the slope of 3, right? They need to have the same slope to be parallel. So I'm just going to go up 3, so 1, 2, 3, over 1, and that's my second point. And all they asked me to do is graph it. I only need 2 points to graph a line. If you want to do a secondary, test yourself on your slope-intercept form equation. Try and write out the equation for the orange line just to test how you're feeling with slope-intercept form. Pause the video and unpause when you're ready to check. Okay, there's your orange equation. Notice it's got that same slope because we need to ensure they're parallel. The y-intercepts will be different. This one hits at a height of 7. Another practice problem. This one is a little bit harder because we first have to graph this equation. So I'm going to graph it in green. Try and pause the video and graph that equation and unpause when you're ready to check. So what I've done is I've graphed my line. Notice that -5 refers to the y-intercept. When you plug in a 0 for x, your y value is going to be -5. That's down here. And then I used the slope of 8/7 up 8/7, which is right 7. We're assuming a positive is right, negative would be left. And then we need to have another equation. So I'm going to make the other equation blue. We need an equation this time, not just a picture, and it has to go through the point 9, -2. Let's see, 5, 6, 7, 8, 9 to the right, and then 2 down. So there's my point. So I'm going to start there, and I'm going to use the slope of 8, 7. Now, here's the tricky thing. I can't go to the right, so I can go to the left. Remember, if you have a slope of up 8/7, up 8, right 7, you can also go down 8, left 7, and go backwards. So that's what I'm going to do. I'm going to go down 8 and right 7. So let's see, that would get to a -10. And then 1, 2, 3, 4, 5, 6, 7. And then that would ensure that I have got the right slope. Now here's what's really tricky about this one. This one's going to be a little bit harder. I know that I've got the slope of 8/7, but I don't know what my b value is, my y-intercept. And it's looking like it's not going to be a cleanish number. So this one's a little bit of a stretch. This is a little bit now more of a mixed level problem. I would say number 2. This was more like a core level problem. But this is good to review some ideas from graphing lines and equations of lines. If I know that there is a specific point on this graph, right, I know that this point exists. My purple point is 2, 10. Oops, excuse me, -10. So I know that when x is 2, y has to be -10 according to that point. So if I plug in a -10 for my y, leave my 8 over 7x. Oh, and x, sorry, should be a 2, right? We're saying x is 2 and y is negative 10. And then plus b. And now what's really nice is I'm able to solve for b algebraically. So I've got negative 10 equals, I can write that as 2 over 1, and then I do top times top, bottom times bottom. 8 times 2 is 16, 7 times 1 is 7, plus b. And now to solve for my b, I just need to do minus 16 sevenths. Minus 16 sevenths. So that means that b is going to be negative 10 minus 16 sevenths. And it's looking, remember how we said it wasn't really going to be a pretty clean number? I might want to rewrite the negative 10 as something in sevenths, right? So that'd be negative 70 sevenths, right? Because if you think about 10 over 1, if you want the bottom to be 7, you're doing times 7 on the top and times 7 on the bottom. And 70 divided by 7 is 10. That's another way to think about it. So now from here, I know that b is going to be negative 70 minus 16. That's negative 86 over 7. Notice that's a nice clean number. So I can take that and plug it into my equation. Negative 86 sevenths. Phew, that was definitely a mixed level problem, right? It was much harder than the previous one. And then let's try another one. Try this one on your own as a double check of how you're feeling about graphing lines, parallel slopes, all that good stuff. This one's a little bit trickier at first. They're actually both vertical lines. Notice the yellow vertical line. Every single point on that line has an x value of negative 6. Like this point here is negative 6 comma 6. Right, negative 6, 0, negative 6, negative 2. So that means that my parallel line also has to be vertical. You can kind of think about this as like planks of wood being used in construction, right? I'm kind of creating a wall vertically. And so the equation of the line, I have to go through this point, negative 3, 11. So the equation of the line is just going to be x is negative 3 because I have to go through that x coordinate. Now, both of these also do have the same slope. Remember, vertical lines, that's an undefined slope. That's why they kind of have a weird equation. If you have a horizontal line, that's where you have a slope of 0. Just to kind of remind you guys about that. And one final question. This one is going to be a good connection back to triangles. So first thing, would you guys pause the video and plot the 3 points for triangle ABC? Okay, so I've plotted my 3 points. Make sure that we're careful counting, and with negatives and positives, all that I double checked to make sure. And I labeled them, color-coded them, made a triangle. Now our task is to take this triangle, and it says, what is the equation of a line that's parallel to AB? So notice that's the segment between A and B, right? Here's our segment. So we need to be parallel to segment AB and go through point C. So remember, parallel, we need to have the same slope. So what is the slope that is through A and B? Let's see, from A to B, I need my rise and my run. It looks like I'm going up 1, 2, 3. And I go over 1, 2, 3, 4. So it looks like your slope is up 3 over 4, up 3 to the right 4. And we need to go through C. So let's follow that slope along. I'm going to get a different color. I'm going to use red, and I'm going to kind of zoom in, and I want to go up 3 over 4. So up 3 over 1, 2, 3, 4. And that's actually perfect. So I need the equation of this line. I know it's y equals mx plus b, and I know the slope has to be that 3/4. So I know I can stick that in right away. And then your y-intercept, I'm going to make that yellow just for color coding. The yellow y-intercept is going to be, it looks like a -1. So I might rewrite that as -1. And that's your final answer. So a nice little connection back to triangle ideas that we saw in our last unit. So that is it for today. On Wednesday, we're going to be practicing graphing lines, making sure we're feeling good on graphing parallel lines. We'll also build in some time just to review graphing lines in general if we need to. See you guys then.